One of the difficulties with fraction multiplication is that it tends to go against our intuition. Our intuition tells us that if we multiply two numbers, the answer should be bigger than either one. But that isn't necessarily true when the two numbers are fractions. That only holds if we are looking at two numbers that are both at least as big as 1. If we multiply two improper fractions, then the product should be larger than either of the two fractions we started with. Why? Well, we take something bigger than 1, and then we make more than one copy of it. So we should have more than the thing we started with. We should also have more than the number of copies that we made. However, if we multiply an improper fraction by a proper fraction, so something bigger than 1 by something smaller than 1, the answer should be bigger than the proper fraction, smaller than the improper fraction. Why? Well, we take something bigger than 1, and we make less than a whole copy of it. That means, well, we should have something more than just the part we took, but something less than our entire original improper fraction. Finally, if we multiply two proper fractions together, well, then the product should be less than either one. We took something smaller than 1, and we made less than a whole copy of it. That's going to give us less than either of the two fractions we started with. These are just things to be aware of, because these are things that make fraction multiplication seem to violate our intuition until we're used to it, at which point this looks like how it ought to be. All right, can we be more specific? In particular, when we're multiplying two improper fractions, we're often ending up looking at really, really big, unpleasant numbers. Can we check that? And the answer is yes, yes we can. To check that we've correctly multiplied two improper fractions, we can estimate. This works even better for the product of mixed numbers, since they are very, very easy to round to the nearest whole number. So let's look at the product. Let's consider 9 3/4 times 8 11/15. I'm going to do two things with these two numbers. First, I'm going to estimate the product by rounding to the nearest whole number. And then I'm going to multiply and compare that to my estimate. So, first, to estimate the product. 9 3/4. That's between 9 and 10. The distance to 9 is 3/4. The distance to 10 is 1 minus 3/4, which we can find pretty easily to be 1/4. This is closer to 10. 10 is the nearest whole number. 8 and 11/15. That's between 8 and 9. The distance to 8, of course, is 11/15. The distance to 9 is 1 minus 11/15, which we'll find pretty easily is 4/15. This number is closer to 9. So we estimate the product to be 10 times 9 equals 90. All right, let's see what we get when we actually multiply. 9 3/4, that'll be 9 times 4 plus 3/4. 36 plus 3, 39/4. 8 and 11/15, that'll be 8 times 15 plus 11/15. 8 times 15 I better write out. 15 times 8, 8 times 5 is 40. 8 times 1 is 8, plus 4 is 12. Plus 11 is 131. So I have 39 fourths times 131 fifteenths. I see a common factor of 3, and that looks like about the best I can do. 13 times 131 twentieths. 131 times 13. 3 times 1 is 3. 3 times 3 is 9. 3 times 1 is 3. 1, 3, 1. I think I get 1,703 twentieths. Writing that as a mixed number, 20 goes into 170 8 times. 20 goes into 103 5 times, with 3 left over. So I get that my product is 85 and 3 twentieths. 85 and 3 twentieths, how does that compare to 90? That's actually pretty close. I would have known that I was way off, for example, if I had gotten something like 400, which I might have gotten if I'd made a mistake in simplifying the denominator. All right, I'm going to give you one of these to try. 16 and 2/3 times 18 and 2/15. First, estimate the product by first rounding to the nearest whole number. Then, multiply and compare. Pause the video and try this now. All right, 16 and 2/3. That's between 16 and 17. How far is it from 16? Well, 2/3. From 17, 1 minus 2/3 is 1/3. So we can see that 16 and 2/3 is closer to 17. 18 and 2/15. That's between 18 and 19, surely. How far is it from 18? Well, 2/15. And from 19? Well, 1 minus 2/15 will be 13/15. So this is certainly closer to 18. So to estimate, we'll multiply 17 times 18. 8 times 7 is 56. 8 times 1 is 8, plus 5 is 13. 1 times 7 is 7. 1 times 1 is 1. 6, 10, 3. We estimate that the product is about 306. And now we'll work out the exact value. Let's see. 16 and 2/3. That'll be 3 times 16 plus 2/3. 16 times 3. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. 48 plus 2/3. That's 50/3. 18 and 2/15. That'll be 18 times 15 plus 2/15. 18 times 15. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 90. 1 times 8 is 8. 1 times 1 is 1. That'll be 270 plus 2/15. 272/15. All right, so when we multiply then, we'll have 50/3 times 272/15. I can see there's going to be a common factor of 5. 5 times 10 times 272 over 3 times 5 times 3. And now doing this multiplication, 2,720 ninths. I'm not 100% sure that there are no remaining common factors, but I certainly can't see any. So now I'm going to convert to a mixed number. 9 goes into 2,720. 9 goes into 2 not at all. It goes into 27 3 times. 9 goes into 2 not at all. It goes into 20 twice with 2 left over. So this works out to 302 whole things with 2 ninths left over. My actual product then is 302 and 2 ninths. My estimate was 306. Those are very, very close to each other. I think that this estimate is definitely in line with that actual product.